Welcome. In this video, we will be going over the examples from Lesson 6 in Module 2 for Grade 7. Here we're going to be talking about a formula to use to find the distance between any two numbers, but we're going to start with the number line to demonstrate how it works. In example 1, we're going to find the distance between -3 and 2. If we look on a number line, we can see that here's -3, and we're going to count the number of units from -3 to 2. It's 1, 2, 3, 4, 5. It's 5 units. Now, this works when the numbers are close together on a number line and you can picture it. But how can we find the distance between two numbers that are really far away? If we talk about distance, distance is always positive. And the way we deal with numbers that are always positive is we use the absolute value. And we can use the subtraction of integers that we've talked about and absolute value together to find distance. Let's do that with this example. If we want to find the distance between -3 and 2, we can use our formula, -3 minus 2, finding the absolute value of it. And remember, we can turn subtraction into adding the opposite. So instead of -3 minus 2, we have -3 plus -2. And remember, we're finding the absolute value of this. Well, -3 plus -2 is -5, and the absolute value of -5 is 5. We can also go the other direction, because remember, distance doesn't matter whether you're coming from the left or from the right. So we could do 2 minus -3. We can turn the subtraction into addition by saying 2 plus +3. We're adding the opposite of -3. 2 plus 3 is 5, and the absolute value of 5 is 5. One way to look at this is we're saying how far is -3 from 0 and how far is 2 from 0, and adding those two distances together. Let's take a look at example 2. We're going to talk about a change in elevation versus distance. Distance is always positive, but a change in elevation or temperature may be positive or negative, depending on whether it's increasing or decreasing. That means going up or going down. In this example, we're looking at a hiker. He starts hiking at the beginning of a trail that is a point which is 200 feet below sea level. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. If we want to know the distance between 200 feet below sea level and 500 feet above sea level, that's positive. And we can use the formula. We're going to say 200 feet below sea level is -200, and 580 feet above sea level is positive 580. And we can use the distance formula, -200 minus 580, and find the absolute value of that. -200 plus -580, I turned that subtraction into addition by adding the opposite of positive 580. That's -780. The absolute value of that, the distance between those two numbers, is 780 feet. That's the vertical distance. And in this case, the change in elevation was positive, right? The vertical distance is 780 feet, but the hiker hiked 780 feet from a point below sea level to a point above sea level. They went up. So it was a positive change in elevation. Now if we look at this after lunch, and here's a picture to help. After lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. So here are the values on a number line. Before lunch, he went up. It was a positive change. After lunch, he's going down. It's a negative change. The distance he goes doesn't change, but the direction he goes does change. So before lunch, it's a positive change. Before lunch, after lunch, it's a negative change. But the distance itself, even if I change the order, 580 minus -200, 580 plus +200, 780 feet. But the change in elevation is 780 feet down. This is an important distinction. If we're talking about the distance, it's always positive. But if we're talking about change, we can give it direction, either up or down, left or right, positive or negative. All right, you should have all this information written down in your workbook, and we'll finish out the lesson tomorrow in class. Have a good day.